Okay, welcome back. Let's go back to 3-2. Let's carry on the Fibonacci thing. So this time, Fibonacci function with dynamic programming. Okay, what what does dynamic programming means? Let me give you a little background of it. So as we remember, just now we did the Fibonacci recursion. So what happened with the recursion is, when you're calculating Fibonacci, let's say 6. Yeah, then you're basing on the Fibonacci 5 and the 4. When you're calculating Fibonacci 5, you're based on 3 and 4. So Fibonacci 4 is calculated twice. So there's a lot of waste of calculation. What about we do something to remember what we have calculated, and then, it saves us a lot of time, So that's what we did here. So what I did is I used the class and I used the memorize function to catch the answers we had calculated by the Fibonacci number, and their value. Okay, so that's what I did. So Fibonacci 0, okay, it's 0. Okay, Fibonacci 1 is 1, and Fibonacci 2 is 0 plus 1, which is 1. Okay, so that's what we did. So now this function is dynamic programming based on the concept. So what we did is we have a definition here, and of the fib. That's what we're gonna run to get the fib. If the n is smaller than 0, smaller than 1, now of course we're gonna return n, because if you want any Fibonacci number that's less than 1, which if it's 0 or 1, it's gonna be 0 or 1. Otherwise, we return memorize the n, which is then we're gonna go here to get what you want to return. So here in this function we have a cache. This cache is the dynamic DP, dynamic programming, DP mostly array. This time we're using a dictionary, and for I in range from 2 to n plus 1, which is the Fibonacci position we want to get, we try to get the I based on I minus 1 plus I minus 2. So this is also a recursion. However, if this answer previously existed, being cached before, then we do not need to calculate it anymore because it's being cached. Otherwise, we're gonna return it and store it in the cache. Cache n equals to store in the cache to store it. So in this case, this function should run pretty nicely. It can. Oh, did it stop? No. So even it's calculating such a big number, 1999999, it's still pretty fast, relatively. We still get the Fibonacci number quite fast because we catch the answer by the time we calculate it, using instead of using recursion. Let me try recursion. I might not be able to run in recursion because I think we have a maximum stack whatever limitation in Jupyter. Let me try. But if we can run it, it's gonna be significantly slower. Okay, let's wait. Okay, so it reaches the maximum recursion depth. So it's apparently longer than this one. So that's how we use a DP to optimize our calculation.